Hey everybody, welcome to 13.5, the Law of Sines. So, the really cool thing about triangles is we can actually find missing sides and area even if it's not a right triangle. So that's what we're going to learn about today. The law of sines is a special formula that allows us to find missing angles and sides for a triangle that's not right. Now, think back, we do know a bunch of stuff about how to find missing sides and area if it is a right triangle. That's what our warm-up is on today. So I will give you a hint. For number one, in order to find the area of that triangle, you're going to need to find what this is. You can use that using the Pythagorean theorem. And then another hint, in order to find the area for number two, you're going to have to also find what the height is. Why don't you go ahead and give this a try, and then when you unpause, we'll have the answers showing for the warm-up. All right, so there's our answers to the warm-up. Number one, the answer is 30 units squared, and number two, the answer is 5.35 units squared. That was me assuming you remembered area of a triangle is 1/2 base times height. All right, so moving right along, in 13.5 and 13.6, we're going to find the missing sides and angles for any oblique triangles, which oblique means it does not have a right angle. Now, there's 4 situations depending on the information we're given. I have them listed here. If I know 2 angles and a side, that determines exactly 1 triangle. If I know 2 sides and an opposite angle, it could be no triangle, 1 or 2 triangles, and that is the hardest one. So that one we're going to do together in class, but I will make a separate video with that in case someone's absent. They can watch that on their own. And then if I'm given 3 sides or 2 sides and an included angle, we actually can use something called the law of cosines, which we're going to learn in section 13.6. I just want to point out something to you, and that is specifically 2 sides and opposite angle will always be listed as side angle, not the other way around. So don't even try it. Ha ha ha. Anyways, let me give you our formula. Okay, so I have my typical triangle with angle A and side A across from each other, angle B and side B across from each other, and so on. And here is the formula. I have it all listed for you. So if I take the sine of an angle divided by its side, it's equal to the sine of another angle divided by its side. And notice the side is across from the angle. And again, to use this formula, we're actually just going to use 2 out of the 3 fractions. You don't need all 3 in order to find a missing side. You just need to set up a little proportion for yourself. One thing that's really key here is that the longest side of the triangle is always opposite the largest angle. The shortest side is always opposite the smallest angle. So you can kind of check your work, because you can always ask yourself, did my longest side end up from my longest angle, and did my shortest side end up from my shortest angle? So that's a way you can just check your work to see if you did it correctly. I'm going to say more about that in a little bit. And then one other thing I want to tell you is you want to always solve for the smaller angle first, if possible. Smallest angle, smallest side first. Sometimes if you do not solve for the smallest angle side first, something happens with your answer, and we're not advanced enough in Algebra 2 to really talk about it, so I'm just going to say one possible, solve for the smallest side or angle first. So here's what we're going to do. We're going to solve the triangle. Solve means I'm finding all of the missing sides and angles. So in order to do this, we need a side angle pair, because I need to fill into my formula an angle and a side that match. So the first thing I'm going to do is find angle A. Now, once you know 2 of your angles, finding the third angle is super easy, because I just subtract from 180. And I end up with 49 degrees. Again, to solve a triangle, we need every missing side and every missing angle. So I've got my missing angle. Now, all right, here's what I'm going to do. You know what, I misspoke earlier. We actually already have a side angle pair. We know that angle B and we know side B. So that is what I can use to set up my proportion. So I'm going to write out the formula the first time here just so you can get the hang of it, but once you get the hang of it, it'll be really fast. In this situation, let's find side A first. So I am going to use this part of the formula that uses B and A. And then what I'll do then is I'll fill in angle B, which is 28 degrees. I'll fill in side B, which is 26. I'll fill in angle A, which is 49, and then side A, I don't know. Okay, now you can write that down. What I'm doing is creating a proportion, and when I have a proportion, I can cross multiply and solve for my missing piece. So when I cross multiply, and this first time again I'm going to write it all out. After that we can kind of take a shortcut, but I've got A times the sine of 28 equal to 26 times the sine of 49. And then, in order to get rid of the sine of 28, I'm going to divide it. So here's what I would do if I was typing this into my calculator. First, I am in degree mode with my angle, so I'm going to check my calculator and make sure I'm in degree mode. I am. Check. Good. Then I'm going to type in 26 times sine of 49, and I get 19.622. I'm going to divide that by sine of 28. Divide by sine of 28, and my answer is 41.8. And I am in feet, it looks like, so 41.8 feet. I want to point out something to you, and that is, in our calculators, if you do decide to plug in all of this at once, you're going to want to put parentheses around the top for most of your calculators. And then be careful because the sign automatically puts a parentheses there, so then I need to do a double close parentheses to make that happen correctly before I divide by the sine of 28, and then I get the same answer. So just be careful with that. I now have 2 out of my 3 answers. Last but not least, I need to find side C. And by the way, the reason I found side A first was because I noticed that I knew that A was going to be the smaller side because A is across from a 49 degree angle, whereas C is across from a 103 degree angle. And then the other thing I want to tell you is when I'm finding my second side, you still want to use the sine of the B over angle B because those were the numbers that I knew the exact answer for. If I try to change this and use A, this is a rounded answer. So if I used A here instead of using angle B and side B, I'm not going to get as exact of a correct answer. I'll be further away. So I always want to use the exact numbers that I was given when possible. Now to find side C, angle C is 103 degrees. So I have sine of 103 degrees over side C. I'll color code it to help you out if needed. Okay, so there you go. So I'm going to, again, cross multiply. And let me tell you, it is always required that you show your setup, but once you get the hang of this, you can type this into our calculator. So if you remember what we did before, I know that I'm going to have to, one more time I'll write it all out just to kind of show you. I know that this is going to happen, that it's going to be C times my sine of 28, and then equal to 26 times sine of 103, and I'm going to divide by the sine of 28. If you know that without typing it in, you can just, or without writing it out, I mean, you can just type it into your calculator right away. Again, writing down the setup is required, but then at this stage, if I knew I was going to do 26 times sine of 103, enter, divided by sine of 128, I can just type it into my calculator at that point. Now I end up with 53.96. If I round to 1 decimal place, that actually rounds to 54.0 feet. And then always ask yourself if everything you've got seems reasonable. If a 28 degree angle is 26 feet, does it seem reasonable that a 103 degree angle would be 54 feet? Well, you know, and it's not quite double, like you might be thinking that this is like 3 times as big, so wouldn't the side be 3 times as big? Doesn't quite work out that way with sine, but it should be much bigger without being super huge. So, you know, those answers seem reasonable. Let's do another one, and then I'm going to have you try 2 on your own. What's going to happen usually is they will not give you a triangle written out, so you need to draw your picture. I never worry about drawing my picture to scale, honestly. I just draw a triangle and throw in some labels. Save yourself some time that way. We don't need everything to be perfect in order to get correct answers. I do like to make sure that if I know a side, I like to label it A equals, just so later. Okay, lost my train of thought because my husband just walked in and asked if I know where our Xbox controller charger is, which I don't. So I don't remember what I was saying just a second ago. So I'll start over. Basically, I always label it A equals. I don't just put 10 because sometimes it's easy to get mixed up when you're doing these. So label them is my suggestion. All right, angle B is 86 degrees, and then there's side B right here. Angle C, side C. Again, angles are always uppercase, sides are always lowercase. Now, I can this time again find my third angle easily because I know two angles. That's not always going to happen. Sometimes I'm going to have to do it the other way around. But this time again I can easily find C. So 180 subtract 31 subtract 86. And I end up with 63 degrees for angle C. Now I need to find my sides. So this time the side angle pair that I am given is angle A. Then I need to decide, so should I find angle C first or should I find angle B first? We're going to want to find angle C first. And just so you know, if you're a really big formula person, this is the part of the law of sines I'm going to use then. But again, you just have to know sine of the angle on top divided by the side across from the angle. Sine of the angle on top divided by the side across from the angle. So in this case, sine of 31 over 10, that is representing my A. And then sine of 63 over C. Okay, and here is where I was saying earlier, again, writing the setup is required, but now I know I'm going to do 10 times sine of 63, and then I'm going to divide by sine of 31. So if you know that right away, you can just type that into my calculator now instead of writing it all out, and I end up for side C 17.3. Really right now, when I find side C versus finding side B, this and this are not affected because I can just use angle A every time, but it's still good to find the smallest side first because it really will matter when we're doing law of cosines tomorrow. So it's just good to get into that habit so that you don't even have to think about it. You just, in your mind, are always trying to find the smallest one first when possible, because it's not always possible. But all right, so again, I wrote down my setup, the required part. I'm going to always use the one that I know specifically, the one that was given when possible, and then this time 10 times the sine of 86 divided by sine of 31. And I get B is approximately 19.4. Once you have that down, on the next page, I've got two problems for you to practice with. Please try at least one of them. Just try it and see if you got this before you move on to the next thing. But again, why don't you pause right now, and when you unpause, I'll have the answer showing so you can check your work. All right, here are our answers. Please check your work. Remember to write down any questions you have so you can ask me during class. Now, if you're someone who's going to be in class, we're going to skip example 2, and example 2 is going to be done on a separate video of how to find a second triangle. So whenever I have SSA, I have to find a second triangle. So what we're going to do actually is go to your third page, so the second sheet of paper front side, and I want to show you the law of sines area formula, and that's what we're going to do to finish out this video. So far, we only could find area with a triangle if I knew the base and height, and if the base and height were perpendicular to each other. That's what this formula gives us. Only if the base and height are perpendicular to each other. So this new formula allows us to find the area without knowing base and height. All I need to know is specifically its two sides and the angle in the middle. Because if you think about your normal triangle here, So this first one is highlighting B, side C, and angle A. Again, uppercase is an angle. So that's a possibility. So again, I need two sides and the angle in the middle. And this is just all the possibilities here. I could have A and C with angle B in the middle. And if I don't know this information, I might need to use the regular law of sines to find a missing side or angle, so I do know two sides with an angle in between. All right, flip to the next page and let's show you. This can be super easy, like example 3A. In this example, I know angle A, I know side B, and I know side C. So I immediately have two sides and the angle in the middle. Again, if I know two sides and the angle in the middle, I fill it into my formula right away. The two sides go in front here, and then I take times sine of my angle. So let's type that in. 1/2 times 5 times 3 times sine of 55, and it is in degree mode right now. I get 6.1 inches squared. So it can be just that easy for some of them. It also can be harder, so please keep listening for part B. So for part B, here's what I've got. I know angle A is 65 degrees. I know angle C is 35 degrees. Side A is 17. I do not right now have the required information because, again, I need two sides and the angle in the middle. So here's what I can do. I do have enough information here in order to find side C, if you look at what I've got. So I can use this as sine of 65 over 17. And I can use this in order to solve for side C. So that is equal to sine of 35 over side C. Again, cross multiply. So I'm going to type into my calculator 17 times sine of 35. Enter, divided by sine of 65. And C is approximately 10.8. Okay, now this is helpful to me because, look, I have two sides. All I need to know, the only other thing I need to know to fill into my area formula is what the angle is. So I've got two sides, I need to find the angle, and that's easy. 180 subtract 65, subtract 35. Oh wait, you know what? I wrote that down wrong, didn't I? Oh no, I'm good. Okay, so 180 subtract 65, subtract 35, and B is 80 degrees. So now I have two sides and the angle in the middle, and that's what I needed to use my area formula. So 1/2 times side times sine of the angle in the middle. And this is a rounded answer, so our answer is not going to be exact. But that is okay because we're just rounding it anyways. So 90.4 feet squared is my area for part B. With example 4, we're going to take our area formula and apply it to a situation. Here's what's going on. You're buying a triangular piece of land shown. It is $1,500 per acre. And we know 1 acre is 4,840 square yards. What is the cost of the land? So, in order to figure this out, first I need to know how many acres of land am I buying. So I need to know basically how many yards am I buying, because then I can convert it into acres. So my first question is, how many yards squared of land am I getting here? Meaning I get to use my area formula, yay. Conveniently, they already gave you two sides and the angle in the middle. So I've got 1/2 times 251 times 173 times sine of the angle in the middle. And I get 20,971 point something something something. For now, I'm just going to write that all out because it is a decimal that ends, and then I can have a more exact answer. All right, so 20,971.69858 yards squared. So that's how many yards. To figure out how many acres it says 1 acre is equal to 4,840 square yards. So I'm going to divide by 4,840 to figure out how many acres there are. And I already have that number in my calculator, so just divide by 4840. So 4.33 acres is what I'm buying here. And it is $1,500 per acre. So multiply by 1,500, and I get my final answer. So the total cost here is $6,499.50 if I round it. So that's really cheap for some land. We're going to do example 5 quick while we're at it here. Example 5 is us just taking our triangle and making it into a word problem. And when they say how wide is the gorge, I'm looking for this value right here. So that's my final goal, is to solve for x right there. Now, conveniently, so remember, I need a side angle pair in order to start my sine of something over its side. I don't have a side angle pair right now, but I can create one right here, because it's going to be easy for me to find this missing angle. Just 180 subtract 10 subtract 105. So this angle right here is 65 degrees. So sine of 65 degrees divided by 50, that's my start. Then the side across from x is 10, or the angle across from x is 10. So there I go, sine of 10 over x. Cross multiply. 50 times sine of 10 divided by sine of 65, and x is approximately 9.6 feet. Go ahead and pause, rewind, watch anything else you need to, and thanks for listening. We'll see you soon.